All right, here we are, learning with Mr. Neff, solving multi-step inequalities. This is like take 4. We'll go for it again here. Solving multi-step inequalities. I like one and done, but I want to do a nice job at it too. So watch my creative target here. I can solve multi-step inequalities. Wow, how'd I come up with that? So that's my target here to focus on. I want to remind you what a solution to an inequality is. One of the vocabulary phrases. It's just any number that makes it true, makes it work. All right, we remember our symbols: less than, greater than, less than or equal to, greater than or equal to, and not equal to. Also, when graphing, you'll remember these produce an open dot, meaning that the number is not included in the solution, and this will produce a closed dot that is included in the solution, these two right here. So something to keep in mind. All right, without further ado, let's jump right in. This is like a two-step equation, it's an inequality. So you're going to treat it exactly like an equation. What I do to one side, I do to the other. So you would tell me I'm going to add 28, right? So then you have 16 is less than or equal to negative 4x. Now the thing we need to remember is to flip the sign in the undo step here that we're going to do. Where after we do the undo step, you're going to say divide by negative 4. But we'll find out it doesn't work unless we do this step right here. So that's negative 4. Flip the sign is greater than or equal to x. Oop, there we go. And so that is my solution. All numbers, x is less than or equal to negative 4. So I'm going to rewrite that very carefully. One of the reasons why I recreated this is because I did not write this correct, and then I went through and I said, well, I just want to remind people how to graph. And so the solution, I don't know what that is. Whoa, we'll call that negative 4. Okay, negative 5, negative 6. I like to see at least 5 or so. I don't have to go by, I start at 0. I could do a different scale, but I'm going to do a closed dot at negative 4, and then I'm going to shade to the right. Okay, and how do I know that that's the right way? All right, well, I'm going to check. Now, this dot could be in the wrong spot, and I could check, because for instance, the solution could have been x is less than or equal to negative 1, and if I check x is negative 5, and it works, well, I could still be wrong, but generally this works pretty well. And actually, the reason why I'm redoing it, because I did the check on the video, and I realized I did it wrong. When I rewrote it up here, I didn't change the sign. So let's do a quick check. Negative 12, excuse me, is less than or equal to negative 4. We'll test it with negative 5. Okay, we'll see if this is true. Is negative 12 greater than or equal to negative 20? Nope, 20, excuse me. There's negative 12 less than or equal to 20 minus 20 is what we have. Whew. Is negative 12 less than or equal to 0? You're like, what's going on? Okay, that's true. I did it right. Let's move on. Example 1. Any questions? Okay, let's move on. All right, here we're going to distribute first and then combine, right? So this is, again, would you do this with the equation? Most of you would, right? Hey, I have wrong letters, though. Let's use x right here. We'll call that x. See, problem solved. All right, no trouble whatsoever. And so we're going to combine 2x and a what? Negative minus 3? No, positive 3x. Yeah, so we have those two. That's a positive 2x and a positive 3x. So 5x minus 2 is less than 2. Then add 2. 5x is less than 4. And then you divide, I got to stop bumping that. And divide by 5. And x is less than or equal to 4/5. Any number. Now, if you had to graph that, just to point out, you could either do something where you kind of zoom in to it, like a 0 and a 1 and kind of about where it is, or you could even go ahead and put in the tick marks to show where 4/5 is, and you'd put an open dot there and then you'd shade. That'd be fine too, to kind of zoom in on that number line like that to see where it is, and just you would be labeling what everything is. The 3/5, I have to cram a little bit. Don't like doing that. Hey, that's pretty good. Yeah, not bad for pen skills there. All right, so let's move on. Hoping I did that right and no one sees any mistakes. Okay, and I did this again, but we'll call this x. I must have been looking up problems and saying I'm going to do x and then wasn't paying attention. That's okay. So first step, all right, let's say I'm actually going to take the harder road just to assume you did it wrong. Obviously, it'd be easier to subtract 4x. I'll subtract 7x. All right, just like you would before, negative 3x plus 2 is less than negative 13. Well, then that means I need to subtract 2 on the one side. Negative 3x is less than negative 15. Oh, look, I got to divide by negative 3. I purposely did that because now I need to flip the sign, flip the switch. X is greater than 5. All right, so any number greater than 5, oh wow, I keep doing that. Any number greater than 5 will make that true. So you put in 6, and real quick, 4 times 6 plus 2 is 26. 7 times 6 is 42 minus 13. All right, that is 29, so that's a true statement. So that shows me I'm probably in the right area there. So my solution is all real numbers greater than 5, and that's how I show that on a graph. Okay, last kind of two, a 4a and a 4b. So real quick, we're going to distribute, and you'll notice something real quick. 14 minus 6n after I distribute, right? Well, oh boy, I see something. But let's take it one step further, because usually in math, we like to get our variable to cancel out, and that's what's going to happen right here. Oh, look what happens. 14 is less than or equal to 14. Is that true? Sure is. What does that mean? That means my solution is all real numbers. It's infinite. Basically, we're saying all real numbers. By the way, how would you graph that? Well, you'd have your number line, all right? You'd have your number line. Make sure we have a bunch of numbers, and you would just shade the whole number line in the arrows. That's what it is. All real numbers. Okay, so that's that one. And then you probably know where I'm going with this now. Most of you will be like, oh, I know where he's going with this. Maybe. He's writing a weird 4. So 4p plus 3 is greater than, combine like terms. And I got 4p plus 6. You can always pause this if you're watching this. All right, now I subtract 4p. Oh, look what's going to happen. Okay, 3 is left on the left, and 6 is left on the right. Is 3 greater than 6? No, I don't think so. No, so it's false, right? And therefore, what's the solution? It's no solution. There's nothing that will make it work. Let me go ahead and graph that for you right now. There it is, right there. It's a blank number line. We're saying there's no number on this number line that would make this true if you put it in for p. Okay, well, that went pretty well, and that was pretty quick. That's about how long I wanted to talk. Again, I went a little fast for you, but that's what the pause button is for. All right, thanks so much. I'm ready to go to bed. Have a good night, good day, whenever you listen to this. This is Learning with Mr. Neff. Peace.